Hey there, pre-algebra students. I'm glad to be able to be here today and enjoy this sunny day that was supposed to be rainy. And so I hope that at some point you get to poke your nose outside of your house and enjoy some of the sunshine. So we're ready to go into a new section now. Okay, we got our feet wet coming back yesterday, and I hope that you were understanding a little bit better about the graphing. So we need to talk today about equations as functions. Now, the thing is, because where we are, it's very difficult to give you an example of an equation that is not a function, just because of the fact that we're not quite far enough along. So all of the equations that I'm going to talk about today actually are functions. And I'll remind you what that means shortly. So the first thing we need to do is we need to take a look at this idea. If you're given an equation, and instead of you choosing the points as if you were going to graph it, the points that they want you to plug in for x are given. If you remember, the word domain means the list of all the x values. So if the directions say to solve, if the domain is, and then it gives you a list, what you are going to do is you're going to take all of the x values that they gave you, and you're going to find the y values that go with them. So in other words, for -4, what you want to do is you want to go back to this original equation, y equals 3x minus 5, and you need to plug in -4 wherever you see the x. Now be careful with the subtracting and the minuses and the negatives. There are still some of you that are having a little trouble with that. So we're going to go order of operations. 3 times -4 is -12 minus 5. And then we're subtracting, so we keep the first one, and then this is really adding -5. So we have -12 plus -5 is -17. So in our chart, we've got -17 for that one. Then we want to pick the second member of the domain. And what we're doing is we're finding the values in the range to go with it. So we're going to use this same equation and find out how much y equals 3 times 0 minus 5. You're always plugging the member of the domain in where the x is and finding the y that goes with it. So 0 minus 5, we've got -5. And then for 2, we have 3 times 2 minus 5. And so 6 minus 5 is 1. And then 7, 3 times 7 minus 5. They all have these things in common, and you're just replacing your x value here. So 21 minus 5, 16. So the way that your answer will look then is it's going to be the set of numbers, and there's sets of ordered pairs. So notice I've got the parentheses, -4, -17, 0, -5, 2, 1, and 7, 16. Now I said we were going to deal with these as functions. If you remember, the way that you tell if a set of ordered pairs is a function or not is you look at all of the members of the domain and make sure that they generated just one answer for the range. So -4 just goes with -17, 0 just goes with -5, 2 just goes with 1, 7 just goes with 16. So this is what we call a function. All right, this word won't mean very much to you right now where you're at, but as you go on and on and on, it will mean more. All right, let's look at another one. I want to do several just because sometimes it takes a while to get get going on these. Here's a new function, and we're going to solve it if the domain is this new set of values. They're going to give you, for each problem that you're supposed to do, they're going to give you a value, a set of values to work with, and then you have to figure out the y value that goes with it. So I'm going to be looking at -2, 1, 2, and 4. Okay, so you're not picking your own values this time. They give you the domain, so it makes one less decision for you. So some people like that a little better. So we're going to plug in here. I'm going to look at -2 squared plus 6. Do make sure you put in the parentheses, because this means something different than if I were to write this. Okay, this part, this notation means that you would do 2 times 2, which would give you 4, and the answer would be negative. But what we're really asking for in this problem is that you take the whole thing and square it, which gives me +4. And this gives me 10 for my value right here. Okay, so once again, be careful of your notation. And this is a problem that I see that doesn't just end in Algebra 2. I see this thing going on. So make sure that when you have a number squared, if you've got a negative, please put it in parentheses so you don't lose any or change any values that you don't mean to. So we'll cut that right out. All right, so let's put in a 1. We want to do how much is 1 squared? I like using this better. There you go. We want to find out how much 1 squared plus 6 equals. That will give me 1. 1 times 1 is 1, so be careful with that. Sometimes people make a mistake there. And so we've got 7 here. And then we've got 2, so we want to try 2 squared plus 6. 2 squared is 4. So we've got a 10 here. And then we finish it up with 4 squared plus 6, and giving you 22. So our set of ordered pairs is -210, 17, 210, and 422. So looking at this set of ordered pairs, some of you might have been like, wait a minute, this one has 2 10s. Can it still be a function? Yes, it can, because it's the x ones that are not allowed to repeat. None of the x ones repeat. It's just the y ones that repeat. So that's fine, and this is still a function. Okay, like I said, I can't really, with the tools that we have right now, I can't really show you a good example of one that isn't a function and still maintain this idea of giving you the domain. So we're just going to have to be content with this for right now. Okay. All right, one more, because this one looks like it should be easy, and it is, as long as you're careful. Solve y equals 5. If the domain is this, and remember our domain is our x values. So our domain is 1, 3, 9, and 87. Well, let's look at our equation. It says y equals 5. It doesn't even mention x. So what that means is that no matter what, y equals 5. So when x equals 1, y equals 5. When x equals 3, y equals 5. When x equals 9, y equals 5. When x equals 87, y equals 5. So this one is the easiest one as long as you pay attention to what it really says. And don't think that you have to do something with this number if this number is not even mentioned. Okay, this is your domain, which really just tells you this is my list of x values, and this tells me that no matter what, y equals 5. So my set of ordered pairs here is 1, 5, 3, 5, 9, 5, and 87, 5 for this domain. Now you could, if you wanted to, you could pick other values, but when it says to solve if this is the domain, then they're looking for just the ordered pairs that you get from this. Now, even though the 5 is repeated, 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 the x values are not, so this makes this a function. Okay? Because each one of the x values goes only to one y value, so we have our function there. All right, that brings us to something else. Okay? We have this idea of a function, and we've been thinking about it with y equals, y equals, y equals. What we need to get you ready for algebra is a new way of notating it. It's called function notation. And in function notation, instead of using y equals, the y gets replaced by a name of a function, usually an f or a g, sometimes an h, and the name of the function of x. So y would get replaced with this right here that says f of x. Okay, this right here that says g of x, or this right here that says h of x. F is the name of the function. G is the name of the function. H is the name of the function. All right, so right now I can almost see the looks on some of your faces where you're going, I have no idea what she's talking about. So we're going to jump into an example. Okay, we have to be very careful when we're looking at these functions, okay, to realize that this does not mean f times x. Okay, this is a function whose name is f, a function whose name is f, and the variable that's used in it is x. This right here is not always going to be the value of function f. Okay, just like when we had y equals and then there was always something after it, but you had to be given what the part after it was, we do the same thing with function notation. This is our function f. And in the problem somewhere, they have to tell you what goes with it. This is our function g, and somewhere in the problem, they have to tell you what goes with it. This is our function h, and somewhere in the function, they have to tell you what goes with it. So a typical question for something like this would be to find f of 10. Now this does not mean f times 10. This means you have the function f and somebody told you what goes with it, and you need to find out what you get when you plug in 10. So what I get when I plug in 10? 10 minus 5, and that equals 5. So the answer to this question is the number 5. Let's do another one. This is f of 4. This is asking you for the value of the function f when x equals 4. So this means I'm going to plug in 4 where x is. 4 minus 5 gives me -1. The answer to this question is a -1. Okay, I know that this is the very, very beginning of this, but we've got to get this idea of function notation down for you to be successful in your algebra classes down the road. So function notation, let's do another one. Let's do a decimal. Let's do 0.5. The value of the function f when x equals 0.5. I'm taking 0.5 minus 5. All right, well, we have a little bit of thinking to do. We need to do keep, change, change. So we're taking 5 is the bigger number, 5 minus 0.5. Don't forget to line up decimal places. So we have 4.5, but it's negative because 5 is bigger. But the answer to the question is negative 4.5. So for each of these, if your problem is given in function notation and it tells you to find a value, you plug in the number and you simplify, and that's it. You're not trying to, you're not multiplying f times 10. You're not trying to get f by itself because this is a whole unit, which means y. And really what this means is that y equals 5 when x equals 10. And it's a shortcut way of writing that phrase out. This one means y equals negative 1 when x equals 4. So it's a way of telling you what value to plug in. All right, let's reboot and make sure that you've got this. If we have g and I want to find g of 12, okay, my function g is defined like this, so I'm taking 1/3 times 12 minus 4. And so 1/3 of 12, if we reduce that, we end up with a 4 minus 4. So my answer is the number 0. Okay, so the answer to g of 12 is actually 0. There's my number, my answer. Let's do another one. Let's do g of negative 3. I'm going to plug in my negative 3. One-third of negative 3, if we cancel this out, we end up with a negative 1. Negative 1 minus 4. Be careful of your rules for positives and negatives. We need to realize that when you're subtracting, you're adding the opposite. And I know there's some of you that really need that again. Keep, add the opposite, keep, change, change, as some of you like to do. So the answer to this one is negative 5. Here's our answer. So g of negative 3 equals negative 5. What this means is that when x is negative 3, y is negative 5, if we were thinking about it that way. Function notation, a whole different notation. Let's do a couple with h. Okay, let's say I have h of 5. If I'm supposed to find h of 5. Now if you're saying, wait, where are these numbers coming from? The problem would say to find these. This would be the problem right here, and then you would do the math to find the answer. This is our problem, h of 5. This part has to be given to you, and your job is to plug the number in where it belongs and then simplify it. So 25 minus 4 gives you 21. That's your answer. And then finally one more. Let's do h of 1/2. Oh no, fractions to a power. Yes, fractions to a power. It's not that scary. You're going to be fine. Oh, I did -4 here, didn't I? Ah, it should be +4. Let's change that to a +4. Okay, so I don't have you sitting in front of me to keep me on track here, so you've got to keep me on track remotely. So +4, this should be 29 then, so make sure you change that. This is 29. So 1/2 squared plus 4, 1/2 times 1/2 is 1/4 plus 4. 1/4 plus 4 is 4 1/4. So we're just putting that together, and here is your answer. Okay, so carefully work through, you do these things. Now, there is a little variation to it. Okay, you've got all these things written down. I'm going to take part of this, and I want to give you another thing that could happen. So I'm going to delete this real quick. Oh, I don't want to crop, I want to cut. There we go, cut. And I want to let's give us another one to think about. Okay, what if, let's use purple. What if instead of doing this, what if the directions said to take 3 f of 9? This 3 actually means 3 times, so this would be 3 times f of 9. So what you would need to do for this problem is you'd first have to find out how much f of 9 equals. F of 9, 9 minus 5. That'll give us a 4. So my value here is a 4. Okay? So that means that f of 9 equals 4, so I can replace this whole thing with a 4. So this means that I now have 3 times 4. And 3 times 4 we know is 12. So this is just one more thing that you can do. If you have the function notation next to the number, all you're doing is plugging in the number. But if you have something else that's with it, a number next to that thing means times, multiply, and we're not really going beyond that in this particular lesson or this particular section, but you can see that you could be able to do many things with a number after you found the value. Okay, so this is your very, very beginning introduction to function notation, where you have functions that are labeled with an f or a g or an h or whatever other variable, not variable, whatever other label you want to put with it. Okay, x is the variable. This whole thing together represents y. X is a variable. This part altogether represents y. Okay, so there's that. I need you to do a really, really good job on the homework assignment. When you enter the homework assignment in, okay, it will ask you to input the even answers. So that's something new for you. So make sure that you have your homework handy when you're doing your homework and when you're submitting your homework. And the reason that I have this is because you can look in the back to get the answers to the odd problems, but the answers to the even problems, I really need you to have access for them, but I need to know that you've given it your best try first. So what you're doing when you are inputting your even answers into the homework sheet is, as soon as you're done, it's going to send you a response, and in the response you're going to be able to check to see how you did, and the answers will be right there. Now keep in mind that when you're looking at those answers that are sitting right there in front of you, the auto mark does not take into account whether you put a space in or whether you um, whether you put x equals or y equals or anything like that. So when you're looking at it, you should be able to tell if you got it correct or not. Even if it's marked wrong, it doesn't necessarily mean that it's wrong. You're going to be able to see the answer right there next to it, and if you're going, wait, I don't know if I really got it right or not, but your answer looks just like the other one and it just accidentally marked it wrong, you're right. But if you really don't know and you're going, I just don't get it, what I'm going to do after you submit them is I will go through them and one more time take a look at them and make sure I can tell you. If you ask and say, I'm not really sure if I got this one right or not, I can let you know that. Okay, because I do get to look at them. And when I do the quiz answers, I do go through and I make sure that it's giving you all the points that you deserve for those things. So that's about it for today. I hope that this made a lot of sense to you and that you have a good day today, and that you're finding some interesting things to do, and that God's showing you some important truths in your life as you go through all this. It's not easy on any of us, that's for sure, but I can tell you that you are important and there is something important for you to do. So keep on the eye as far as God revealing that to you. All right, have a really blessed day.